In the previous video, we talked about the NewTS framework architecture and demonstrated how to create, test, and modify test cases which are, strictly speaking, sets of instructions for an instrument's soft panels. Just as a reminder, the NewTS framework comprises the execution engine and instrument's soft panels. The sequencer, the execution engine, does not communicate with the physical instrument. Instead, it sends instructions to the specific instrument's soft panel application. Further, the soft panel sends an corresponding command to the physical instrument. If to compare the NewTS framework to the dedicated test application or the TestStand. Because these two use instrument drivers, they are like bits and pieces of a car put inside a container. In contrary, the NewTS Soft Panel is the whole car and the execution engine is the driver. The philosophy behind the soft panel design is to replicate a real instrument's appearance and functionality as much as practical. This approach greatly reduces the software learning curve because if you know how to operate the real instrument, you mostly know how to operate the soft panel as well. As it was mentioned above, each soft panel has a list of arguments from which we can compose our sequences of instructions, which will be formatted into UDP messages and sent to the corresponding instrument soft panel. However, it should be noted that putting the sequence together is quite a tedious activity, even if you become familiar with this process. It is the same as manually setting a real instrument. Because of that, instruments manufacturers came up with such features as save and recall the instrument settings. Since it is the internal functionality of the instrument, it executes much faster than via Visa or any other interface. Since we are using soft panels, we have an opportunity to generate the instruction sequence much faster. We have available NI-USB 6343 instrument and the soft panel for it. It should be noted that the NI-USB 6343 does not have the user interface on its own. Each control of the soft panel has the user menu. Insert at the top of the sequence. Insert at the end of the sequence. Replace selected instruction. Insert before selected instruction. Insert after selected instruction. The soft panel has a special page, sequence, dedicated to operations with instruction sequences. As you see at the moment, it is the empty table. Let's go back to the analog input page and start the sequence generation. But, before starting, let's verify that the analog input settings are correct. We will go to the analog output page, change the output voltage to 5 volts, and press the Generate button. Now we go to the analog input page and press the Measure button. The average measurement indicator will show about 5 volts, which is expected, proving that our analog input settings are correct and that we are ready to generate the sequence. Setting up the analog input physical channel. Setting up the analog input sample mode. Setting up the input terminal configuration. Setting up the maximum input voltage limit. Setting up the minimum input voltage limit. Setting up the sample rate. Setting up the number of samples to be acquired. As you see, the instruction sequence works perfectly fine with text boxes and numeric controls. But we have to register the Boolean controls that have the momentary action, such as the Measure button. To do that, the soft panels have the Add Last Action to Sequence button, which registers the user event, in this case, the button press, and adds its state to the instruction sequence at its end. Now, let's go back to the execution engine and test editor page, and add the new test case 1.3 import AI settings from file demo. There are no instruction sequence associated with this test case. Right-click on the test case configuration table and from its user menu select the Import Sequence from File item. We have to select a sequence source, the instrument's soft panel, which will be controlled by that sequence. In our case, we have to select NI-USB 6343. The Import Sequence from File window will open. As you see, the Sequence File Names selector is populated by the file names that were created. We will select AI test CFG file and press the button Open. Now the test case configuration table has become populated. Let's select the button Insert at top. The test case configuration table of the execution engine also became populated by instructions we just opened from the selected file. And the last thing we have to do is to save the test case. As you see, the generation of the instruction sequences in the soft panel allows for saving a lot of time compared to the manual generation in the execution engine. After importing the sequence from the file, all we have to do is to add the get function and save it to the memory functions. There is still another method of configuring the instrument's soft panel which was borrowed from the instrument's manufacturers. Let's open the NI-USB 6343 soft panel again and go to the sequence page. There you can see the small section settings. The selection type allows you to select which type settings are analog inputs, analog outputs, digital inputs or outputs, and counter. Let's select the type of analog inputs. And set the number of settings to 1. Now, press the Save button. It will result in all analog input settings being saved into the configuration file of the soft panel. Let's go to the analog input page and change the values of existing controls. Now, let's go back to the sequence page and press the Load button. The stored values should appear in the analog input page, and they are. Let's go to the execution engine, the test editor page, and create the new test case 1.4. Recall settings demo. We will select our instrument NI-USB 6343 from the list. And the argument 1 should be set. Argument 2 will be the settings type, the analog input. Add this instruction to the test configuration and press the button Save. And the settings number we will set to 1. Add this instruction to the test configuration and press the button Save. And, finally, we will set argument 2 to the settings load. And, add this instruction to the test configuration and press the button Save. To demonstrate how it works, let's go to the instrument's soft panel analog input page and again, change the values of controls. Now we have to go back to the execution engine test editor page and press the Execute All button. We can go to the soft panel and verify that the analog input controls were properly updated. As you see, the instrument's configuration time is reduced to 724 milliseconds with the execution of just 3 instructions. This concludes our demo video, and if there are any questions, please leave your comments.